So here we have the function sine 5x plus 3. So we need to find its derivative with respect to x. So what we're going to do, we're going to assume that 5x plus 3 is equivalent to x. It's just an assumption. So that means we are finding the derivative of sine x. So which should give us the sine of x. So x here is 5x plus 3. But that being an assumption, so what we do, we multiply it to the derivative of the assumed function of x, which is 5x plus 3. So that gives us cosine of 5x plus 3 times, so derivative of 5x is going to be 5 and derivative of 3 is 0. So finally we get 5 times cosine of 5x plus 3. So this is the derivative. Let's move on to the next question. So we have the function tangent squared x. So we find its derivative with respect to x. Now tangent of x whole squared, tan squared x can be also written as tangent of x whole squared. So now if we assume that our tangent of x is equivalent to x, then we have d over dx, or the derivative of the function x squared, which is simply twice x. So that should give us 2 times tangent of x times the derivative of our assumption, which is tangent of x. So derivative of the tangent function is secant square x. So we have 2 times tangent of x multiplied to secant squared x. So that is the answer. Let's move on to the next question. So here we have the function sine of log x. So we need to find its derivative with respect to x. Now we're going to assume that log of x is equivalent to x. Then we have derivative of the sine function, which is simply cosine of x. So cosine of x, x is log of x. Then we need to multiply it to the derivative of the logarithmic function. So the derivative of log function is 1 over x. So we have 1 over x multiplied to the sine of log of x. So that is the answer, which has been found by using the chain rule. Let's move on to the next question. So here we have the function e raised to the power tangent of x. So let's find the derivative with respect to x by using the chain rule. Now if we assume tangent of x equals to x, or equivalent to x, then we have e raised to the power of x, and the derivative of the exponential function is the function itself. So we have e raised to the power tangent of x multiplied to the derivative of tangent of x. Now tangent of x is secant squared x. So we have e raised to the power of tangent of x times secant squared x. Let's move on to the next question. So here we have the function e raised to the power sine of square root of x. So let's try to find out its derivative with respect to x by using the chain rule. So we're going to assume that sine of square root of x, if it were equivalent to x, then we have e raised to the power of x. So the derivative of the exponential function gives us the function itself. So we'll get e raised to the power sine of square root of x times the derivative of the assumption, which is sine square root of x. Now we are going to assume that square root of x is equivalent to x. So that means we are finding the derivative of the sine function. So we have e raised to the power of sine square root of x times derivative of the sine function gives us cosine square root of x. Then we again multiply it with the derivative of square root of x. The square root of x can be also written as x raised to the power of half, and then we apply the power rule, which gives us half times x raised to the power of half minus 1. So we have half times x raised to the power of negative half, or we have 1 over 2 square root of x. So we have e raised to the power of sine square root of x times cosine square root of x divided by 2 square root of x. So this is the derivative of the given function with respect to x, which has been found by using the chain rule. Let's move on to the next question. So here we have sine squared 2x plus 1. Now we need to find its derivative with respect to x. Now what we're going to do is we're going to rewrite sine squared 2x plus 1 as sine 2x plus 1 whole squared, so that we can assume that sine 2x plus 1 is equivalent to x. So that means we have x squared, and we can apply the power rule, which is 2 times sine 2x plus 1 whole raised to the power of 2 minus 1 times the derivative of sine 2x plus 1. Now we're going to assume that 2x plus 1 is equivalent to x. So we have derivative of the sine function, so that gives us 2 times sine 2x plus 1 times derivative of the sine function is cosine of 2x plus 1 multiplied to the derivative of 2x plus 1. So derivative of 2x plus 1 is going to give us 2. So we have 2 times 2, which is 4, sine 2x plus 1 times cosine of 2x plus 1. So this is the derivative of the given function with respect to x. Let's move on to the next question. So here we have logarithm of 2x minus 3 to the base of 7, and we need to find its derivative with respect to x. But first we need to change the base of the given logarithm. So this can be written as log of 2x minus 3 to the base of e divided by log of 7 to the base of e. So here we have applied the property that log of a to the base of b is equals to log of a to the base of e divided by log of b to the base e. So now we're going to apply the derivative. So log 7 is a constant, so we have 1 over log 7 to the base e, which I'm not writing here, times the derivative with respect to x of log of 2x minus 3. Now we're going to assume that 2x minus 3 is equivalent to x. So then we can apply the derivative to log of x, which gives us 1 over x. So we have 1 over log of 7 multiplied to derivative of log of 2x minus 3 is going to give us 1 over 2x minus 3. Now we're going to multiply it to the derivative of our assumption, which is 2x minus 3. Now derivative of 2x minus 3 is 2. So we have 2 over log of 7 multiplied to 1 over 2x minus 3. So this is the derivative. So let's write it down in a more simplified form. So we have 2 divided by 2x minus 3 times log of 7. Let's do another problem. So here we have 2 raised to the power of x cubed. So let's find its derivative. Now this time we are going to assume that x cubed is equivalent to x. So that means we have to find the derivative of 2 raised to the power of x, which is equals to 2 raised to the power of x times natural log of 2. So that means we should get 2 raised to the power of x cubed times natural log of 2. But x cubed is an assumption here, so that means we have to multiply it to the derivative of x cubed. So derivative of x cubed is 3x squared. So we have 3x squared multiplied to 2 raised to the power of x cubed times natural log of 2. So this is the final answer. Let's move on to the next question. So we have tangent of 5x degree. So let's find out the derivative with respect to x. So for this we're going to assume that 5x degree is equivalent to x. So we have to find the derivative of tangent of x, which is equals to secant squared x, which is 5x degrees, times derivative of 5x degrees. Now x degrees, so we need to convert it to radian. So we know that pi radian is 180 degrees is equals to pi radian. So which means 1 degree is equals to pi over 180 radians. X degree will be equals to pi x over 180. So we substitute x degree with pi x over 180. So we have secant squared 5x degree multiplied to the derivative of 5x degree. So that will be 5 pi x over 180, or simply pi x over the 36. Pi x over 36. Now pi over 36 being a constant, we can pull it out. So we're pi over 36 times secant squared 5x degrees times the derivative of x. So derivative of x being 1, so we have pi over 36 multiplied to secant squared 5x degrees. So this is the derivative of our given function tangent of 5x degree, which has been obtained by using the chain rule. Let's move on to the next question. So here we have tangent of x degree plus 45 degree. So we're going to assume that x degree plus 45 degree is equivalent to x, and then we try to find out the derivative of tangent of x. So that gives us tangent of x is secant squared x. So x here is x degree plus 45 degree. So that means we need to multiply it to the derivative of our assumption, which is x degree plus 45 degrees. So that gives us secant squared x degrees plus 45 degrees times the derivative of x degrees plus derivative of 45, which is 0, 45 being a constant. Now x degree, we can convert it to radian, which we have already done in the previous section. So x degree will be equals to pi x over 180. So let's replace it with pi x over 180. So we have secant square x degree plus 45 degrees times derivative of x degree, which is pi x over 180. So pi over 180 being a constant, we can pull it out of the derivative and write it in front of the function secant squared x. So we have derivative of x, which is 1. So the final answer is pi over 180 times secant squared x degree plus 45 degrees. So that is the derivative of the given function.